Okay, my friends, you might find this a little hard to believe. I do. This is a space science alert. Something weird is going on in the sun's atmosphere. We just got a big clue. This just came out today. Now here's the sun, and it's got all these magnetic fields and flares and sunspots. It says the sun as seen at solar orbiters perihelion on 26 March 2022. So that's about a year ago. There's something really odd about the sun, a lot of odd somethings about the sun, but a groundbreaking space probe just given us the clue we might need to solve one of them. So what is the clue? The new observations from European Space Agency Solar Orbiter suggest a constant reconnection of tiny magnetic field lines may be at least part of the reason why some parts of the sun are so much hotter than others. Well, I can show you why they're hotter than others, but this is unbelievable, really, as far as I'm concerned. It says, well, it's a star, obviously it's hot. Well, of course it's hot, but listen to this. On the surface, it's 10,000 degrees Fahrenheit, 9,932. Well, let's go with 10,000 Fahrenheit. Now, a normal temperature for a sun-like star, yeah, that's fine, 10,000 degrees, that's normal. But the material in its atmosphere, which is the corona, grows hotter the further it gets away, peaking at a baffling 2 million degrees, way out away from it. Why was that? Why could that possibly happen? It's way up there in the atmosphere. That's the corona. Well, I know why it happens. It's because of the scrub. They've known about this from 1940, but they still, even today, are unable to determine why. All right, my friends, let's just start out with what we're dealing with is space. We are spinning through space just like everything else. What is space loaded with? Particles. It's saturated with particles. They don't ever even consider any of this stuff. We have to plow through this stuff. It's absolutely very, very simple to understand why. And here's the hot spots on the sun. This is the sun right here. And these are the poles. You see coming straight up and straight down. And this is all swishy going around here. Well, the reason is, let me show you what the sun looks like as it travels. Then I can explain these hot spots. Now watch. This is the sun as it travels through the arm of the Milky Way being pulled like this. Let's look at the Milky Way. But first of all, understand that the sun is plowing through all that debris I showed you a minute ago. I think I showed you here. All of this stuff. Space is saturated with debris. I mean, it's totally saturated with debris. Even, well, I'm going to show you stuff that cannot be denied, and nobody is denying it. They just don't, not even thinking about it. Nobody is denying quantum foam. It exists. This is almost 10 years ago. The foam on the head of a root beer is very complicated, always bubbling and changing. Empty space experiences similar activity with the subatomic particles winking in and out of existence. Particles that are in space, winking in and out of existence. The reason is when they wink is because they got slammed into. Anytime you slam into a particle, it will glow for a second because of that impact. So they're winking in and out of existence, slowing the light coming through it, quite obviously. These particles are real and have a measurable impact on our universe. This is Fermilab. This is not just Billy Bob saying this. This is Fermilab. And they realize it's absolutely real. There's no question about it. And here it is. There it is. I mean, you can't, how could you possibly miss this? Absolutely amazing. All right. Not only is the quantum foam real, also, this is the quantum foam. These are the particles that are coming off the sun and from every radiant source. These are the particles of light. It's called the muon neutrino and electron neutrino. And I show this in very, very good detail. And they do exactly what they say here. The fixed particle is the black one, and the other one is a point-like particle, has no mass, but it has a field. Precisely correct. No argument with that whatsoever. Now, these are those particles. There's the black and white ones that I just showed you a second ago from Fermilab. They make photons. Each side is a gluon. Two gluons together make a photon. Photons, as they grow mass, they turn into protons, neutrons, and so forth. Now, I'm going to show you what's happening in space and why our atmosphere is heating up, why the sun's atmosphere is heating up, why we have these very glowy spots on the sun, which they're talking about. I can't explain any of this stuff. Millions of degrees out here, 10,000 degrees on the surface. Well, guess what our atmosphere is? It's thousands of degrees out here. Thousands. And 100 or so on the atmosphere. How do you get thousands up there? That's where the global warming is coming from. And the same thing with the sun. I'm going to explain this in extreme detail, uno momento. Okay, let's just start with a galaxy. And we are in a galaxy. I don't know if it's this galaxy or not. We're in the Milky Way. But what is happening is in the center of galaxies, there is a gigantic black hole. And I can show you this in pretty good credibility. And what happens is the more that black hole grows, the more white matter wants to get attracted to it. That's why it's spinning as it's literally falling into that hole. And all of these are spinning, and as the white pushes against other whites, they create these interference patterns. That's what they've always thought was the double slit experiment. It's not. These are interference patterns because of the magnetic pushing to these particles. They don't want them to be next to each other, and they set up these lines. They used to call them the interference patterns. Now don't forget, this is spinning like crazy. Now we could be on one of these arms of a galaxy. We are somewhere in the Milky Way. Are we coming through dense material? Are we coming into crossing a pattern like this where we might come into blank material? It appears that our atmosphere is being really invigorated now, and I think we're coming into some dense space. However, the other possibility is it's just that we have exploded our envelope of gases so far out now that the scrub is intense. Every single square centimeter, literally, in the universe is packed with particles. And I think I showed you, but I'll make sure I show you again. It's the quantum foam. All right, we're going to go back to this in a second. Here's the quantum foam. It's everywhere. Here's exactly what it says down here. Quantum foam is real. The microcosm is continual motion of all these little winking on and off particles, these charged particles that are streaming away from the sun. This is what's happening in our solar system. All right, here's the sun. It's being ripped through the arm of the Milky Way, which I just showed you, the arm of the Milky Way. Everybody's spinning around, falling into the dark hole. We're on one of those arms. So this has to go through. The sun has to push through whatever particles are in front, and it washes across the sun, and it spews out all this stuff, only from one side of the sun, because the sun is spinning as it's going forward. I'm going to show you that, and I can prove that as well. All the planets have to plow through whatever the sun sheds off. And what is the sun shedding off? Well, let's take a look. Don't forget, I showed you the sun is circling around here. This is a solar eclipse. What that means is the moon is basically the same size as the sun when we're looking at it. It completely shadows the sun. So we're not blinded by the light. We can see what's coming out of the sun. These are the poles. You see it down and straight up, straight down and straight up. You have a north and a south pole. Why do we have poles? Why do we have all this magnetism and all these rays coming out of here? Here's the reason. You see that red spot? That red spot? That red spot? And you see how they're like a field around and a field around it and a field around it? The sun, which is behind here, is spinning in this direction exactly like this, and being pulled on the arm of the Milky Way that way. So what does that mean? You have excessive concussion here, here, and here, because the ball of the sun is twisting this way, scrubbing harder because it's going in that direction, and it's being pulled in this direction. So it's not only being pulled here so the stuff would stream away, it's also spinning, so it's forcing this twice as hard or more, which creates these hotspots. And they create it here, here, and here, because each field pushes the other field away. You can see it, it's very obvious. Now, on the trailing edge of the sun, which is spinning this way, it's letting the particles come with it, so they're not so concussed. They're, you still got a little bit of action going on there because it's being really pulled through the arm of the galaxy very, very fast. Huge galaxy, and it's being pulled fast. And we can see it's completely saturated with particles. All you have to do is look at the Hubble Space Telescope or the Webb one, the new one. It's just 100%, and they know this. This is what kills me. How can they not take these as particles and be in the... And then they say, well, everything's going away from us because of the redshift. It's pulling all the planets away because it's pulling the light with it. No, it's not. The light is shifting red because it's getting slower and slower and slower as it comes towards us. That's what's going on. All right, the real bottom line is here's what's happening to our atmosphere right here. The sun is getting its corona being scrubbed way out here at millions of degrees scrub. It's only 10,000 on the surface. That's the only reason, is because of the scrub. Same with us. Over 2,000 degrees out here. 100 or so, a little over on the surface, basically. 2,000, more than 2,000 out here. That's the scrub zone. All of this is completely saturated, absolutely totally saturated with particles. And we're scrubbing through them, as I showed you before. This is not in question. It's not in question. This is the reason is they just don't want to talk about this stuff not being a vacuum. It's not a vacuum. They know it's not a vacuum. It destroys everything. It destroys all of their physics. Everything I show destroys their physics because the particles that make up the nucleus are all little tiny dipoles. Don't forget now, this is us. This is where the space station is out here, and it's very low density, low particle. Look at here. This layer, way out here, the ionosphere, 1,500 degrees. I don't know, that must be talking, I don't know, it's close to 2,000 or more than 2,000 degrees, but let's say 1,500, I don't care, that's enough. And it burns up meteorites when they come through this layer because they're pushing through a whole bunch of stuff. That layer is filled with particles. And it's scrubbing out at this layer here. This is where their 1,500 degrees is. It's working its way down. It's down to minus 80 here. All right, but right now we're in trouble because we're either expanding our envelope so this layer is getting further and further out, which gives you a bigger and bigger target to get more and more activity in the atmosphere, and that's what's happening here in the United States. I don't know about everywhere else, but I'm telling you, these tornadoes are absolutely horrifying. And I understand what's happening with the tornadoes now because of this cool layer, the separation of hot and cold. Whenever you can make a tremendous difference between the hot and cold, you're going to get ice forming, and then when it comes down in these huge balls of ice, then the actual particles fall to the earth with a vengeance, spinning. It's just a really dense, heavy layer of particles falling literally to the earth, spinning. That's what a tornado is. And the more we grow our atmosphere this way, or if we're hitting soup, the denser it is that we're plowing into is going to create a different reaction in the atmosphere. Are they looking at these temperatures out there? Are they looking at, you could probably see it with radiation. All right, because they're going to create different amounts of radiation out there. This is your real low radiation area here, and here's your really now. They should be able to tell something about this zone between the ionosphere and the rest of space, which is not a vacuum. It's scrubbing. They should be able to see some kind of signature that tells, is it getting worse? Is it getting better? Is it hot? What's going on there? And these are some something that was done by Rod Warren's nephew, Dylan Carpenter. I mean, these guys must have something in the atmosphere over there in New Zealand and Australia. I don't know, but I can tell you what, that I believe is the moon. Now the moon is moving, and it's getting a blue shift here because it's moving, I believe, in this direction, crushing the particles of light in front of it. It's not spinning, so it doesn't have a field. Somewhere else has this field. There's a planet behind here or something. Again, I don't have all the answers to this, but I can tell you what, I got a lot of marveling. I believe this is Venus, and the reason I believe that is it's got two fields. You see this one here, the real sharp looking one, and the dipole, and then you got another one coming out of here, which is a fainter one. Venus is spinning backwards and going forwards. It's spinning backwards and going forwards. That's why it's getting such a tremendous dipole effect. But all of the planets, and I believe all the planets and virtually everything's dipoles. There is nothing but dipoles. You're going to have a glowy side, and then you're going to have a not glowy side. Nobody's ever known about the not glowy side. They've always known about the glowy side, which is this one here. The little white particles. Everybody's known about those. And they know about them at CERN, too, and at Fermilab. Here they are right here. They're the same particles I just showed you. They know they're there, but they don't understand what their nature is that they're stuck together, and two stuck together is a bar magnet, which is really an electron. Nobody ever knew the black was there. They always saw this, and this would burn stuff and make electricity and all that, but this was stuck to it, nobody knew it. And they see it in their collisions. They call them gluons. And these are quadratic couplings, which is nothing more than photons. Yeah, this light research is pretty serious, and it shows how all of the gases and everything in the air has all these little glowing electrons make these things up. And whenever you push against anything, it's going to glow. That's the nature of energy. Mass is energy. Mass is only created by an impact. There is no mass to anything until it hits something. It's just sitting there. It's massless. It has a weight. Weight is not mass. Mass is the energetic value, which is concussion. And the faster it's going, the more mass it has. The harder it is that it impacts the thing, the more mass it has. If it hits a pillow, it doesn't have much mass. If it hits a brick wall and it's going fast, well, there's a lot more mass. So there's a lot to be considered here, but we can accelerate light, we can slow light down, we can see the particles, we can see the fields that they make, we can see the concussion, we can see the particle wave duality. Nothing here is hidden. Zero is hidden. This is the reason we have the problem we have right now. This is the global warming. And this is the turmoil in the atmosphere. It's just scrubbing the hell out of this and turning all kinds of issues with violent weather. Just like on the sun. See that? These are like tornadoes on the sun almost. Basically the same sort of activity. And we are very, very similar to the universe. Light is almost exactly identical to what happens in the galaxies. Almost exactly identical. You see that? That's light coming this way. It just spins. It spins in a circle. Light spins in a circle, and the black pushes away from the white. Or, well, I'm sorry. The white pushes the other white away, setting up the lines of interference. All right, let me just be sure I explain this correctly. The light is coming here with a pulsed red laser, and it's just going bip, 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 and then all of a sudden you see this Venturi where it has to force itself to accelerate, and that's exactly what it does. So the particle, which creates a wave because of the magnetism, all of a sudden goes zip, and bam, it divides here. And you see right there? These right here are what they call interference patterns. And on a wall, it would show up different, like, spots on the wall. And they say, well, that's because it's flat and flat. This is a single wave, a single slit. And these are separation zones because white doesn't want the white next to it. They hate each other, they push, they shove, they glow. This is precisely what Fermilab and CERN say. The muon, electron, neutrino are attached together. When they see them hitting heavy water, the muon goes on its own, stays exactly the same. I agree. The electron turns into showers. I also agree. And here they are right there. The black ball just separates, completely separates. It just goes on its own way. And it never changes the size. That size is the same size as the over here, over here, over here. They can lay right on top of each other. They don't care. That the black matter, fine. That's dark matter, that's gravity. It will pull everything into it. It wants to be back with the white, but it can't get back to the white when that white is so charged up. So it digs in around the edges. And then about here, it starts to really dig in. But you can see every single edge has the white and the black sort of fluttering around together. And when they hook up together, they become basically invisible. But during the time that they are hooking up together, you can see them. And here's what they look like when they're hooking up together, right there. You see, first the white comes through. Here's nothing there but white. All of a sudden, pew, these pop up. And then a couple seconds later, well, not a couple seconds, but instantaneously, they're gone. They go back into being just like you're looking through the air right here. There's nothing there anymore because they're not concussing. The concussion is over. All right, remember I talked about mass is related to speed and how hard the thing is you're hitting? Well, this is just air. This is nothing but the atmosphere. There's the Venturi, up and down. It's the same Venturi. Now, the red laser is on the bottom part of the Venturi. The green laser is above it. Both of them coming through at the same time. The red has no real energy, basically, because it's just not spinning fast enough. See how it's brown and dull looking? Radiance is energy. Now, the green is so powerful when it impacts this new medium, because it's been broken apart. It's impacting virtually a new medium, just like I showed you the muon, electron, neutrino. And now the muon is basically going on its own, and we're seeing these showers. And then they sort of recombine. The red has already recombined, it's gone. And now it's back into just blackness, but it'll be blackness. But the green still has a lot of value left to it. So it doesn't finish combusting until it comes out here. And it basically, I think of it as combustion. It's reattaching, or it's the opposite of combustion, I guess you'd call it. The white part is being reattached to the black part, and when that happens, they don't glow like that. The glow is down to where you really can't see it until, well, you can't see it because it's just not radiating anymore. The whole key is impact into a new medium, whether it's a wall or a pillow or atmosphere or heavy water. Is going to have an effect on the two particles, because the black one is the mass, and the white one is going to say, whoa, whoa, whoa. Because if it's coming into anything that has electrons, then everything has electrons. So it just depends on the speed of the laser. And it's the colors, the red, green, blue, basically, is the three colors that they mostly talk about. I'm sure all the other colors can exist in different levels of spin, because that's just what the spectrum is. I don't think you can say you only got red and you got green, you got blue. No. You got bluish, and then greenish, and yellowish, and then red down to where you just got your background radiation. So it's almost not moving. And it's all over the place, because that's nothing more than heat, basically. Now, there's nothing more than I would like to have a discussion with Anton about the Schumann Resonance. They still don't understand even why global warming is happening. They don't understand the Schumann frequencies. They call it the diurnal phase. It's total mystery to them. Diurnal means daytime, and the daytime phase is because the rays are being pushed against our atmosphere, crushing it. Let me show you what the Schumann Resonance. It's unbelievable that the people that are in charge of NASA and JPL and all these places, they think space is a vacuum. It's completely saturated with particles that are impacting our atmosphere. Simple as that.